This week we're talking about 4.5 area of a circle. The area of a circle is pi times r squared, but we're going to start off first by reviewing our circumference because that's what we did last time. So if I have a circle, I need to know what the diameter is. And in this one, the diameter equals 4. We'll say that's 4 centimeters. It's just really darn big. So we have circumference was pi times the diameter. That was our old formula. So we just had pi times diameter. Pi was 3.14 our diameter. So my estimate here, if I've got 4, so 4 times 3, my estimate, 4 times 3 would be, it should be around 12. But when I actually put 3.14 in like that, I end up with getting, that is 12.64 centimeters. And so that means the distance around my circle is 12.64 centimeters. So that was your quick review, but now we're going to get into the actual area of a circle. When I'm doing the area of a circle, whenever I do area, I always imagine like a grid, imposing a grid. So if I actually took a grid and imposed it, we're trying to figure out how many square centimeters, we'll say in this case, are in a circle. Now, when we're doing that with a rectangle, it's really easy because squares fit evenly into rectangles. However, in a circle, it doesn't happen because you have these partial rectangles that aren't quite filled. And so it becomes quite the conundrum to find the area. But luckily, we've had some pretty smart people figure this one out for us. So we're going to find the area of a circle like this. And we're going to say that area is pi r squared. So first, we have to find what is r. R is the radius, which is the distance from the middle to the outside. We already know pi, and squared would be this times itself, or the radius times the radius. And this will be our answer. But before we get in that, I want to take a quick look at some of the pictures here in the assignment. We're going to take a look at a few pictures right here. Now, if I had a pizza, and I cut that pizza into slices, once I have these slices, I can start rearranging them. I could rearrange them like this. And you can see it's almost like a rectangle. But what if I cut my pizza into really thin slices? Really thin slices. Well, now when I line them up, look, it's less bumpy like that, and the edges are a little less curved. This is almost a perfect rectangle. Well, imagine that I went at it with a molecular laser, and I cut each of these slices into 4 or 5 or 8 slices of their own. These lines would smooth out more and more until I had virtually a perfect rectangle. If I measured the area of that rectangle, I could find what the area of the pizza together would be. Suddenly, getting that grid fitting in there works much better. Pardon me for the swaying camera. Let me try to adjust that. So now that we see this, we can start to figure out the area. This is the circumference of my circle because these are the outside, the crust of my pizza. So if I measure what the crust is, I would get the outside of my pizza. The distance from the outside of the crust to the very center, that's the best, tastiest part, that is the radius. Pardon me, I'll try to adjust this swaying of the camera once again because it seems to be shaking a bit. So if you see when I line up my slices, the distance from the crust into the centerpiece, that is my radius. So if I look at this, if I were to cut this into triangles and reassemble it like a circle, I could take this and find the area of the circle. Now, why did we go through this? I'm just trying to explain how we figure this out. I always imagine these guys in ancient Greece wearing their robes, drawing in the sand with a stick, trying to figure out how are we going to get the area of a circle. It's nigh impossible. But once they thought of this, about taking those pieces, lining them up, cutting them smaller, lining them up, they realized you could also take a rectangle, cut it into many, many, many small triangles, and essentially get a full pizza. So what did they come up with? Basically what they came up with, they said, well, let's say I had a rectangle and I wanted to turn it into a circle. Then I would take the circumference equals 2 pi r. Tongue tried. I paused the camera for a moment because when I saw circumference equals 2 pi r, I got a little confused for a moment. And then I realized that's because we were talking about the rectangle. Because we have two circumference questions here. What we need is the base of the triangle. So I'm going to save you a little confusion here because it gave me a little bit of a moment of pause. The area equals pi r squared. So when I'm looking at this problem here, I need to find what the radius is, square it, and times it by pi. So let's take a look at an example right here. I'm going to draw your attention up to the board. We're going to say that my radius is 3 centimeters. So what I have now is I have a formula. This formula needs to solve this. I'm trying to find what area is. Now I know what pi is. Pi is 3.14. And it's times r squared. Times because they're directly beside each other. When two things are directly beside each other, they are multiplied. But what does this little 2 mean? Well, first, I have the radius is 3. 3 squared. 3 squared means if I had a square that was 3 on each side, how many squares would it be? It would be 9. Or that would be equal to 3.14 times 3 times 3. Once I have that, I can punch that into my calculator and I can figure it out. Just for simplicity's sake, instead of using the pi button, I'm going to use 3.14, which I accept in our classroom. And I now have 28.26 centimeters squared. And I use squared because that is an area. Now, I don't quite expect you to get it yet, so I'm going to show you yet another example. Let's take a look at the area of one of our pillows up at the front of the classroom, and we'll see if we can figure out what it actually has for surface area. So we've got one of our pillows here. I'm going to use my ruler and I'm going to measure it. We're going to do this in centimeters. So I'm measuring this pillow, and it says that the diameter is 42 centimeters. So my diameter is 42. Now I'm going to start by writing my formula, because that's always where I begin. Area equals pi r squared. Area equals 3.14, that is pi, times the radius. Well, I don't know the radius, I know the diameter. But I know radius is half of the diameter, so it must be 21 times 21 squared. Well, 21 squared, if I go into my calculator, 21 times 21, oops, equals 441 times pi. Hold on, I think that messed up. It's 138474 centimeters squared. Now that sounds like a lot, so I'm going to do a quick estimate on this. 3 times 400 is about 1200. We're at 1300. That seems reasonable because my estimate was 3 times 400, which is 1200. And this answer is not far off. It's in the ballpark. So I must be correct. So to review that really quickly, I wanted to know the area of one of our pillows. I can't really measure accurately from the center out because I don't know exactly where the center is. So I measured right from side to side, and I found that the diameter was 42. Once I had 42, I knew the radius was 21. I wrote my formula. I replaced pi with pi, r, the radius, with 21. Then I did this exponent to get 441. Pi times that total, and I had 1,384.74 centimeters squared. Now these are quick lessons. I don't expect you to watch them and just got it. But that's what I'm here for. This is to supplement. Come on in, you can have my break times. I'm happy to answer any questions. The only stupid question is the one not asked. So come ask some questions.